Hi everyone, welcome back. Today we are going to talk about differentiation. So this is part of the some field called calculus. Okay, so it is really important. I have to stress this because for your uni studies when you go to university, so this one will be like the first topic that you will learn. I would say not to say the first one, maybe something to prepare you for this topic. Then followed by integration, which you will learn in Form 5. Okay, so those are the major things that you will need for the math part. About like 70 to 80% of the math, you are going to use differentiation and integration. So unless you are not required to have any math, or else I really strongly recommend you to go through this one slowly and have a better foundation before you go on to the university. All right, so let's get this started. Okay, so first of all, I will start on 9.2 because 9.1 is never tested and it's something about concepts, okay? So I will give you some kind of like concept here and there, but I will not like do it like a formal session, okay? Okay, next. Now again, so for this one, paper 1 will consist of 1 or 2 questions, not too many. Okay, but it will carry about 3 to 8 marks. Maybe one question 3 to 4 marks, and 2 questions will be about like 7 to 8 marks or 6. Okay, and also in paper 2, it will normally have one question. That question will have a lot of small parts and mainly focus on the like a continuation one. So maybe like 9.3, 9.4, they join them together and have a few parts. Okay, so and again, I have to stress that this one is closely related to integration. So if you do not know anything about this one, in Form 5, you can't proceed. Okay, it's not a difficult topic, so I guess you have to learn this. Okay, all right. Hi, wake up now. So let's talk about basic differentiation. So like I said before, 9.1 is not included in your exam, and it's all about some simple concepts and something that a little bit technical. So those things I'll pump you like from time to time. Okay, so I won't create a separate section for that. Okay, so just dive into this one. Okay, first, the derivative of a function. So like I want to talk about England again. I mean English. Okay, so England. So now differentiation is an action, right? Okay, differentiation is an action. Okay, differentiate is an action. Okay, you differentiate is like a verb, right? Okay, so what is derivative? It is the outcome of the differentiation. I differentiate, I get this one, then this is called the derivative of that thing after you do differentiation. Okay, so let's see. So this is your function y, or you can write it as fx. Then if you differentiate it, so this is an action to differentiate this function, right? You should get another function. Okay, so that thing is called either dy dx or f prime x. Okay, are you okay with this? So meaning that, let's say your function is given in terms of y, then the derivative is dy dx. Okay, dy dx. And if your function is given in terms of fx, then the differentiation of it or the derivative of it is f prime of x. So I want to stress this. This one is actually not division. Okay, it's not dy divided by dx. Okay, it's actually one object itself. Okay, but if you still don't get too much of this one, you can temporarily take this as division, because a lot of times you say, this one, the result shows that this one is actually like division. Actually, it's not. It's just like a rate of change. Okay. So it's how fast the y is changing with respect to x. Let's say something like a length. So I call y the length. I call x the time t. So this is how fast the length is changing with respect to time. Okay. So we will talk about that one in more details later on. But now I just want to let you familiarize with these symbols, these notations, so that you can proceed. Okay, with ease. Okay, so now this one function, okay, function, of course you are okay. This notation here, d dx is an action, is differentiate. Okay, what do you differentiate? you want to differentiate some function. Okay, differentiate some function. Let's say this function, the variable is x itself, then you are differentiating with respect to x. Okay, differentiate the variable x. Okay, then the results will be dy dx or f prime of x, depends on the function. Okay, so this one is a function. Okay, and this one is called the derivative of y or the derivative of fx. Okay, the derivative. Okay, normally how do you call it? You just call it, oh, this is a differentiation of that one. The correct word to use is derivative, but no harm using the differentiation. Okay, it's just how we communicate, right? Okay, so let's move on to the next one. Okay, formula here, right? Okay, so if y is x to the power n, then dy dx, the derivative or the differentiation of x to the power n is nx n minus 1. So what does it tell you? When you differentiate this x to the power n, the n power, you just bring it down, and the power, since you bring it down already, the power minus 1, right? Okay, so that's how you do it. So this is like the basic formula, and the formula that you're going to use like throughout the whole chapter and even further. Okay, so let's look at an example here. So y is equal to x to the power 3. So dy dx is equal to, yes, clever, 3x squared. Okay, 3x squared. That's very simple, right? 3, you bring it down, then power 3, you minus 1, you get 2. Great. Next, if y is equal to k, k is a number. So constant means a number. So if, like, let's say y is equal to 5, then you differentiate it, you should get 0. Okay, differentiation of any constant, you will get 0. Okay, so for this one, y is equal to 6. dy dx you get? Yes, 0. Okay, let's move on to the next one. So if y is x squared, of course, you get dy dx is equal to 2x. So if you have something that has a decimal places here, so a number or a fraction, so is it possible to bring this down? Yes, it is okay, because there is no condition mentioned just now, right? So 0.2, you can bring it down, so 0.2x, then what will be the resulting power? 0.2 minus 1, which is negative 0.8. So you get this. Okay? Make sure you are fine. Huh? Okay? If you are okay, you may try all of this by pausing the video first and do all this before we come back. Okay? So next, y is equal to square root of x, which is equal to x to the power 1 or 2. Why don't we directly work on this one? Because we do not know what is the power, we can't bring it down, right? Okay? We want to make use of the same formula, so we have to have some kind of power here, so that I can bring down the power minus 1. So now dy dx is easily seen. Half x negative 1 over 2. Okay, so can you rewrite this one? Using your knowledge from chapter 5, indices and so on, and power. So this one, what do? It's equals to 1 over 2 square root of x. Because x to the power negative 1 over 2 means what? X to the power negative 1 over 2 means equals to 1 over x to the power 1 over 2, which is equals to 1 over square root x. Okay? Then the 1 over 2 is here. 1 over 2 is like multiplication, so you can write the multiplication 2 multiplied by this one. Okay? I think should be fine. This one is the easiest one, right? Easy stuff. So y is a number, you differentiate it, you should get 0. Clever. 0. Next, differentiate, you get 0. Pi, how does it do it? How do you do it? Is it 4 pi divided by 3? Answer? No. You are finding dy dx, right? Dy dx, so pi is what? Pi is 3.14159 and so on. So that will be a number. Number squared is still a number. Multiplied by 2 over 3, it's still a number. So this whole thing, you can see it's a number. Differentiate this, you get 0. Okay? Don't get fooled by this one. Okay? Although it looks a bit weird there. Okay? A little bit complicated, but it's differentiation just 0. Alright? Let's go. Basic differentiation laws. Very, very important. Pay attention to all this. Okay, so if you have y is equals to the sum of two functions, then the derivative will be equal to the individual differentiation. So what does it mean is that if you have f plus g, then the differentiate will be f prime plus g prime. So differentiation of each of them, then add them up. Okay. Secondly, constant multiple. So if you have y is equals to k, which is constant, multiplied by a function u, then the derivative or the differentiation will be equals to k, write it outside, then multiplied by differentiation of u. Okay, means constant you can bring it down, then differentiate. Okay, these two very simple. The next two is the next two are very important. Okay, first one is called product rule. You have to remember this. Formula provided or not, that's another thing. But this one you should remember this for the rest of your life. Okay, so okay, y is equal to u dot v. U dot v means u times v. Okay, u times v here. Then dy dx is equals to. It looks a bit difficult, but it's not. Okay, I'll show you how. Okay, u dv dx means u keep it unchanged, differentiate v, plus v keep it unchanged, differentiate u. Okay, so this one, there's a short form. I just write here. Okay, so y is u times v, then y prime is uv prime plus vu prime. What does prime means? Prime means differentiate. Okay, differentiation of v, differentiation of u. Okay, it's very easy to remember this one. Right? Okay, keep one, differentiate another one, plus keep another one, differentiate this one. Okay, easy. Okay, so now quotient rule. Something like this one, okay? Quotient rule. If you have one function divided by another one, then dy dx will be equals to, okay, look at this one and look at this one. What's the difference? Difference is that you keep the bottom first, differentiate top. Okay, keep the bottom v, differentiate u. Minus, okay, this one very important, huh? This minus sign. Okay, that was a positive sign. So if you switch these two orders, it's fine. But now cannot switch the order. You have to go from the bottom, differentiate top, minus top, differentiate bottom, minus u times differentiation of v, then divided by v squared. V was below, then you square it. Okay, it's not dv dx squared. Okay, it's just v squared. Okay. So now I give you a short form for this one. So y, if it's equals to u divided by v, then differentiation of y will be equals to vu prime minus uv prime divided by v squared. Okay. So pause the video, try to read these two things, product rules and also quotient rule, and then you continue the video. Okay. It's very important for you to remember all this. Okay. All right, fine, you agree? Okay, let's move on. Differentiation formula. It's called a formula in SPM, but then it's the thing from the previous slides. The 4 laws that we combine, we come up with this thing. Okay, I'll show you how. Okay, the formula is that if you have y is equals to like 2x to the power n, 2x to the power like 5, something like that, then the derivative or the differentiation will be the power you bring it down, right? Power you bring it down then becomes kn, then x to the power n minus 1. I guess you're smart enough to understand this whole thing, right? Because of what? Okay, I'll show you how. Let's say y is equal to k times x to the power n. Then y prime will be equals to k. You see, k, I can bring it out first, right? Okay. Then inside I differentiate x to the power n. Differentiation of x to the power n will give you nx n minus 1. Remember the property, constant multiplied by a function, the derivative of the differentiation will be just bring out the constant, differentiate the function, right? Bring out the constant, differentiate the function. That's what we get, which is exactly this one. Okay? Where this one is a constant, this one is a function, right? Okay? This is a constant function. That's why you can separate them, differentiate the function only. The constant, bring it out, later multiply it back. Okay? Great. So this one I treated as you know already. Okay. So this part will be derivative of x to the power n. Okay, so that one is fine. Okay, example 2. So it's time for you to pause the video and try this yourself. Okay? So then we come back to try this. All right, so now it's my time to show you. So in case you have you have done it already, you can check here. If you are all correct, maybe you don't have to listen to me, okay? But if you can, just listen to one or two so that you get an idea of how you should write your thing, okay? Okay, so now if y is equal to 3 times x squared, then dy dx you can do what? Constant in front, right? I can just write the constant outside. Then differentiate x squared, I get 2x, right? Okay? Okay, no problem. So the answer will be 6x. Check the answer, 6x is correct. Okay, next, this one is the same thing. If you are slightly faster now, so you get this one as 4 times 5x. So it's 4 times 5x, so it will give you 20x. Wait, 4 times 5x to the power 4, I didn't see this power 5. Okay, so now it's power 4 here, so it's 20x to the power 4. Okay, sorry about this. X to the power 5, inside should be 5x to the power 4. Okay, then this one is it 3x? 3x, differentiate, definitely will be equal to 3. That's so easy. Okay, next one, square root 6. What's the answer? Can you get the answer immediately? Yes, you can. Okay, you don't have to do this. Y equals to square root 6 is equals to 6 to the power 1 over 2. Then y prime is equals to I mean dy dx. Okay, I don't write y prime because you are not used to it. Dy dx is equals to 1 over 2, 6 to the power negative 1 over 2. Is it correct? Okay, no, it's not correct. Huh? Okay, if you want to think about this one, you can also think about this is wrong. Okay, later on I'll tell you how to do it. Okay, so this one is a constant. You differentiate, you directly get 0. Nothing. Okay, 0. Okay, yes. Okay, next one. Again, I'm going to do this. Pause the video and I'll show you the answer here. So you can try this one first. Okay, quickly do it. All right, so let's get back to this. This one, again, I can quickly see it's negative 5 right on one side. 7, you take it down, so it's negative 35 x to the power 6. Okay, check answer, negative 35 x to the power 6. Then this one, does the negative 2 affect you? No, it doesn't. So negative 2, you bring it down. The coefficient will be 2 times negative 2, which is negative 4. Okay, now x originally was power negative 2, so now minus 1. Minus 2, minus 1, you get minus 3. Okay, check answer, minus 4 x to the power 9 minus 3. Okay, how about this one? I want to point out one of your common mistakes. You guys write this. Normally, you guys write this. Y equals to 3 x squared. It's very common that you either next line, you want to find dy dx, right? Okay, next line you directly write, oh, okay. So this one directly give the answer for this one. Okay, so so let's say for this question, it's like 3x to the power negative 2. Then next one, it's easily seen that you can differentiate it, right? Okay, differentiate is equals to negative 2, you bring it down, becomes negative 6x to the power negative 3, and which is the answer. Is this correct? No. What is wrong with this? Answer me. What's wrong with this? From first line, this one of course is correct because you copy down. Until second line, is it correct? Yes, it is correct because this one to this one, you didn't make any changes. From second line to the third line, what changes do you make? You differentiate it. Okay? From here to here, it's not equal anymore. So this one is y, this one is also y, but this is dy dx. Okay? So you got to remember how you write this thing. See whether this one is this one or this one is actually the differentiation. Okay? Don't simply write the equal sign. Okay? So for this case, I just write one more time for you. Y is equal to this thing. You write in index form. So x to the power negative 2. Hence, you can differentiate it. Becomes negative 6x to the power negative 3. Okay? Negative 6x to the power negative 3. No problem. Okay, similarly for this one, the y should be equals to, what do you get? Yeah. So here, don't get confused about this one. 2 over 5, you can write as a constant. So it's 2 over 5 then this one is x to the power negative 4. Is that okay? Okay, just make sure you get this one right. Okay, you don't write 5x to the power 4 the whole thing power negative 1. Huh? It's slightly more difficult that way. Okay, so all right, now got this one. Then differentiate it. The negative 4 you bring it down becomes negative 8 over 5 x to the power minus 4 minus 1, so you get minus 5. Okay, negative 8 over 5 x to the power negative 5. Okay, if I write this nicer, it will be negative 8 over 5, then x to the power minus 5, you can write it down there, becomes x to the power 5. Okay, so same as this one now. Okay, so let's move on. So for this one, again, I want you to try this, and of course, pause the video, and okay, so I stand here, okay, and try this with the answers here. Okay, all right, so let's do it. First of all, for this one, what do you get? You get cube root of 2 divided by pi. Is it a difficult question? Not really, because what? You have to remember pi is a number, and cube root of 2, of course, is a number, right? Number divided by number is still a number. If it's a number, you differentiate, what do you get? Kosong? 0. Okay? 0. So that's simple. You get 0. Okay? Second, y is equal to 3 over 2 cube, multiplied by cube root of x. So this is not 2 power 3 here. This is like cube root, then 3 here. Okay? Cube root, then cube root of x. Okay, so for this one, you need to rewrite this one first. Okay, so still remember what is cube root? Cube root means x to the power 1 over 3. Power, root. Okay, power first and root. Okay, so you get this one. So now, here it's 1 over cube root of x. Correct? Correct? Okay, 1 over cube root of x means 1 over this one. 1 over this one, 1 over means 1 over, correct? Means what? X to the power of negative 1 over 3. Okay, meaning that this is 3 over 2 x to the power negative 1 over 3. Hence, if you do this one, constant you can bring it out first is 3 over 2, then bracket negative 1 over 3 x to the power negative 1 over 3 multiplied by negative 1 over 3 minus 1, what do you get? Negative 4 over 3. So negative 4 over 3. Okay, so we got this. So final answer, cancel off. So minus 1 over 2, then x to the power minus 4 over 3. Okay, check the answer. Minus 1 over 2, x to the power negative 4 over 3. So it's fine. Okay. Okay, right. Next here. Is it something that you need quotient rule to do it? No. Okay, no. Why? This one is still something that is, can be do it in a simpler way. So top will be what? X to the power 1 over 2. Okay, bottom will be x. So x, I write 1 here. Okay, so this one will be what? X to the power a divided by x to the power b. You get x to the power a minus b. A minus b. So this one half minus 1. Half minus 1. So x to the power negative half. Okay. So this is x to the power negative half. Then differentiate this. It's easy. X negative 1 over 2, you bring it down. X, then top. The power will be negative 1 over 2 minus 1. So negative 3 over 2 minus 3 over 2. And hence, you get this answer. Okay, no problem? Good. So I'm giving you more questions here. So try to pause the video and try this. The answer is given here. And I'll come back to solve it for, with you. All right? Okay, so now, first one here. It looks like a function like with two functions here. Some function plus another function. So in order to differentiate this, is differentiate them separately and add them up eventually. Okay, so this one, differentiate 3x squared, you give you 6x. Differentiate negative 2, it will be 0. So no need to write. So add them up plus 0, I don't write. Okay, so the answer is 6x. It's fine. So I get rid of this. Okay, so next. Here, it's written in like fraction form. So you don't like it because x is below. Okay, so you want to write in another word form, like in index. So x to the power -1, then minus x to the power -2. So here, if you differentiate it, it's very simple. -x, -1, -1, -2. Then -2, bring it down, become +2. Then x to the power -3. So if you write it nicely, it's -1 over x squared. Then plus 2 is on top, x about -3, so x about 3 below. Okay, so we got this one, which is the same as your answer. Okay, next. Square root means what? X to the power 1 over 2. Cube root means x to the power 1 over 3. Then you differentiate it, and they are like addition or subtraction. So you just differentiate them separately and add them out or subtract them later on. So 1 over 2, x to the power -1 over 2, minus 1 over 3, x to the power 1 over 3 minus 1, what do you get? You use your calculator, you cheated. So minus 2 over 3. So here, final answer, if you write nicely, it will be 1 over 2 square root of x. The other one will be minus 1 over 3, I write it here first. X to the power 2 over 3 is supposed to be below, right? Okay, because it's negative on top, means positive below. X to the power 2 over 3 means you write x power first, then root. Power first, then root. Cube root. Cube root of x squared. Cube root x squared, cube root x squared. Okay, so they are the same one. Okay, no problem. Okay, last one. Here, the first part is very easy. 2 over 3 you can bring it out. Then x to the power 3 you differentiate. Okay, how about this one? I want to point out that if you do this, you see here, if you do 3 over 2x cubed, then you write it as 3, then 2x to the power 3, then minus 1. It's okay, but you need to know what you are doing. Huh? So then 3, then multiply by 2 to the power -1, then x to the power -3. So these two should be combining to form one thing. Hey, what is this thing actually? 3 times 2 to the power -1, which is 3 over 2 lah. Okay, 3 over 2, which is the same as here. So how you should see this is that you shouldn't take this as one whole thing. You should think of this one as one whole thing. Okay? You bring that constant completely outside. Then you just look at 1 over x to the power 3. Okay? So that's the hints that I give you. This is for this one. Okay? In case you don't know. See? Okay? So this is 2 over 3 x to the power 3. Then again 3 over 2 I bring it out as well. 3 over 2. Then x to the power -3. Okay? No problem? Okay. Then we start differentiating this one, right? Okay? We start differentiating this one. So I'll get 2 over 3, then multiply by 3, x squared. Okay? Then next will be plus 3 over 2 multiplied by -3 x to the power -4. Okay? So both things, if you add them up, this one will be cancelled off. So it's 2x squared minus 9 over 2, then x to the power -4. So I can write x to the power 4 below. Okay? Then that's what we get. Okay? You're fine with this? Happy? Okay. So if you have anything, just pause the video and go back. Okay? So if not, we are here at the homework section. So this is your homework. Okay? This is your homework for today. It will take you maybe 10 minutes. Okay? So next will be, so you want to see the answer, you pause the video and I'll give you the answer here. Okay? Next slide is the answer. So answer is here. Okay? So just check your answer, see whether it's correct or not. Okay? I'll see you next class. Bye.